Welcome back, everyone, to the last session of our Seminari Papirologici Torinesi, second edition. And I'm really grateful to Isabelle Marthot Sant'Agnello for accepting my invitation. Let me spend a few words for presenting her. She's a professor for Papyrology at the University of Basel. And she studied in Paris under the supervision of the great papyrologist Jean-Luc Fournet. She's an expert of Greek papyrus material of the Roman and Byzantine age. And at the same time, she has a great expertise in digital humanities and in particular in digital paleography, computational paleographic dating, papyrus imaging. This is a new research frontier in our field of studies. On these topics and many others, she wrote a lot of articles and other publications. I would like to mention the important ongoing project she's leading at the University of Basel, namely the project on which she is going to speak to us today, project EGRAPSA, retracing the evolutions of handwritings in Greco-Roman Egypt thanks to digital paleography, but she also directed other projects which I would like to mention here, namely reunity fragments, identifying scribes and characterizing scripts, the digital paleography of Greek and Coptic papyri. Just a few days ago, we had Paola Buzzi in Turin, and we had the occasion to speak about the importance of Coptic papyrology, all more so because since we are in Turin, where a lot of Coptic papyri are stored. And last but not least, the project Change and Continuities from a Christian to a Muslim Society, Egyptian Society and Economy in the 6th to 8th centuries. Isabelle, thank you for accepting our invitation, for staying here, and the floor is yours.
Thank you very much. I'm very happy to be able to present my research to you. I'm very sorry not to be in person, so I hope that there will be other opportunities soon.
Absolutely.
Of doing recently. I have a message that said that the connection is not so good, so maybe I will turn off the video if it's good for you, and we'll keep just with the slides. You may feel like me that AI seems to be everywhere this recent 2 years with ChatGPT and other chatbots, with AI generators of images. And I would like to show you how I have been using AI recently. But in order to make this use clear, I have to make a little step back in the past to explain how I got in this situation. So why would we want to use AI on papyri? And it's not only a trend, a fashion of the day. So the idea started quite a long time ago when I was still finishing my PhD study. I was studying the place names in the village of Aphrodito in Middle Egypt, which is famous for the Dioscurs archive, which I will go back later in this talk. And in this scope, I was cataloging all the place names, and I received a message from a colleague from Heidelberg saying that he had been looking at this small fragment of papyrus and has identified place names that had a flavor, a taste, a sound of Aphrodito. And when I looked at the papyrus, I could immediately recognize a feature that was familiar to me. You may see on the screen, for those who are a bit familiar with Byzantine handwriting, that we have a specific abbreviation of the word topos. You see the tau, then the sinusoid, and the small omicron, which is quite unusual because the tau and the sinusoid would be enough. Why would you put an omicron after the sinusoid of abbreviation? And this I had already encountered. I remembered exactly on which papyrus I had seen this specific way of abbreviating topos. And thus, with a very quick check, I could find that this small fragment was fitting perfectly the missing part of this larger papyrus from Berlin. The layout fit, the handwriting fit, the content fit, so it is a joint. Then I was really wondering, how can we systematize these similarities? How can we find such similarities across images? Because you see, if we could do a join, if we could make this reunification, it was because of a series of previous knowledge of toponyms, of place names, and the period, and around Aphrodito. It was not pure hazard. So I had in mind this question of being able to search through the images to find specific traces or shapes. And then just after my PhD, I had the chance to take part in the first digital humanities project for me. That was in 2014 as a crowdsourcing project called Ancient Lives. At that time, the platform Ancient Life allowed anyone to go on internet and annotate papyri from Oxyrhynchus. It had been born from collaboration with the Zooniverse platform, which was specialized in crowdsourcing projects and was born by Astronomics project classifying galaxies. And it had proved that in 1 year, the crowd has achieved the equivalent of a full-time 3-year specialist. So it was really extremely promising. And in this postdoc, I was able to work with bioinformatics and computer scientists that were, for instance, applying DNA comparisons to the Greek letters. And I was very impressed that methods for DNA could also be useful for papyri. If you're interested by the Ancient Lives experiment, I can advise you to read this article by James Bruce-Willis, Engaging Greek Ancient Lives, in the book edited by Gabriel Baudard and Matteo Romanello, Digital Classics Outside the Echo Chamber. And then, after this experience, I had the chance of taking part in several events in digital humanities, and one was ManuScience in 2015, where manuscript specialists of different period, different writing systems, different materials, were talking with specialists of chemistry, of physics, and of computer science to combine the different approaches. So that's where I started to conceive my research project on the searching through the images. You certainly know that in papyrology, we are quite advanced in digitization. So we of the 80,000 published text, we have roughly almost all the documentary ones that are encoded in papyri.info. That gives 60,000. And what is missing still are mostly the literary and paraliterary texts that are not complete yet. And thanks to a general effort of the owning institutions, we have more and more images available online. And that leads to something like more than 30,000 digital images of this text. So the material is really at hand and keeps growing. I don't have the time, and it's not the topic today, to talk about the digitization of papyrology and all the projects. I can only recommend the book by Nicola Reggiani from 2017. There are 2 more volumes that are case studies, Digital Papyrology, Volume 2 and Volume 3. But to go back to my research, I was really wondering as an editor and how to find similar handwriting to a given papyrus. Because when you work with fragments that come without context, that have reached the their modern location and owning collections through the antiquities market, then sometimes you have to rely on the shape of handwriting to find joints, and you cannot only rely on formulas or on external data. So that's how my first project was born. As Christiane kindly reminded, it was called Describes, and the goal was to reunite fragments, identify scribes, and characterize scripts. It lasted until June of 2023, and I will present today 2 of the 3 topics that were already in Describes and that we keep working on in EGRAPSA. So writer recognition and script characterization. And the third one, the evolution mechanisms within handwriting, is part of the second project that is Describes, that is EGRAPSA, that was born from Describes as a follow-up and a larger perspective than the pilot project Describes. So, first point, writer recognition or writer identification. Some of you already may know some of the researches on writer identification in papyrology. For example, a study that is absolutely remarkable is the one by Giuseppina Azzarello on the hand of Epagatos within papyri found in Emeria in the Fayum from the 2nd century of our era. And Professor Azzarello applies the traditional methodology, that is to compare with a lot of details the features of the handwriting. And she provides, for instance, a long table with all the letters and all the shapes of and an exemplary shape of each of the letter of the text she has been considered. And one element of this study is that she has this warning in a note that these paleographic reflections are still hypothetical because it points to a similarity. But the similarity between the scripts may not come from the identity of hand. So indeed, these handwritings are similar, but does it mean that they are similar because they are written by the same person, or that they are merely similar because they are from the same period? And that is really a challenge that we are all confronted to when doing writer identification. So ideally, we would prove not only that this alpha, beta, gamma, like there was in the synopsis table, are indeed similar, that would be the blue dots in the circle, but we would have to prove that they are different from the handwriting of all the other persons. So of course, in the traditional papyrology, when you are bound to a paper format of printed editions, you cannot provide examples of all the alpha of the papyri found in the same place at the same period, for instance, as comparanda. But in the digital world, it is much easier to be able to handle a larger set of data. And this is the method that have been used in writer identification in general. So in computer science, there is a specialty around this topic. So it is a research topic. And there are two ways of asking this question of the writer. So you have a series of examples in the database with different person and their handwriting. And then you can either ask, when you have one text, which one is the writer? That would be the writer identification. So you expect from the computer the name of the writer as response A, as 1, and then possibly 2 and 3. Whereas the writer retrieval is the idea to find the similar hands. So find the documents that are the most similar. So the response will be, this document looks like this document. This topic has been quite studied because it's motivated by forensic and all these authentication concerns. One of the main databases that are used for this task is a database called IAM that has started to be published just before the year 2000, so quite a long time ago now, and it gathers a large quantity of writing examples. But as you see, this is nice black ink on white paper. No problem of preservation, no problem of color, contrast, etc. On this almost perfect data set, the current methods in writer identification reach an accuracy of 98%. And you see, it was already in 2021. So on this data set, the task is perceived as solved. The problem is solved for the computer scientist, and they have the method that allow to find at 98% the correct writer among a list of possible candidates. So how does it work when it's on historical documents? For this, you have, for example, this study by the University of Cassino around Professor De Stefano, already from 2018, dealing with the Avila Bible. The Avila Bible is from the 12th century, and experts have estimated that there are 12 different scribal hands that goes from the 12th to the 15th century. And on this data set, the computer was able to recognize the 12 scribal hands at 96% accuracy. So very encouraging even for historical documents. But you see that it is parchment and a large quantity. So I was really curious to know how this method would apply on papyri. For this, I had the chance to work with Hussein Mohammed from the Center for the Study of Manuscript Cultures in Hamburg, who had developed a tool for writer identification. And he gave me the very good advice to start by gathering what is called the ground truth. The ground truth is a data set for which the writer is known. So we are for sure of the name and identity of the writer of the different texts that are in the data set. So the idea is to ask questions to the computer that we already know the response, while spontaneously we would like the computer to respond to question we don't know the response. But if we don't know the response, we don't know if the computer is good, is right and correct when he gives some response. So that is the idea of evaluating the performances on a ground truth. There was no ground truth already in papyrology when I started in 2018. There was no, for instance, there is no section in Trismegistus that would list all the known writers with all the passages that are assigned to their hands. So I had to collect this data. And as I told you, I have been working for my PhD on the Dioscorus archive. So the Dioscorus archive is the largest archive from the Byzantine period. We have 700 texts that come from a single village over a little more than 1 century. I knew this archive, and also the archive has been studied by Jean-Luc Fournet, for instance, and several other scholars. So there were already studies to lead me to navigate through these texts. In this book, for instance, you have the complete list of texts that are considered to be from the Dioscorus archive. And also, Professor Fournet had already collected the images of these texts in the BPAB, that is an online catalog for these images. So among the Dioscorus archive, I decided to work on notaries, the text written by notaries. And some of you may know that there is also, on the topic of Byzantine notaries, this very important book by Dietert and Verp from 1986. So I started to collect the handwritings of the known notaries and to annotate the images and the different parts that were written by the different persons. I had the chance to have a student assistant that would help me. And by doing so, we also improved the annotation on papyr.info, where you may know that the changes of hand are not systematically marked. It should be, but there are plenty of text where the changes of hand had not been properly encoded. So this is an opportunity for me to invite you, if you are in similar situations and you notice that some data are missing from papyr.info where they should be entered, do not hesitate to enter them, and you will be credited as it is due. So you see, for instance, here, you have the name of the student assistant, Johannes Nussbaum, and the justification of the addition of the information. And for the younger students that would want to be fully credited for their work, I take the chance to remind you that you have a public profile you can link on your CV, where you can point to all the great work you have been doing by contributing to papyr.info. So this is an important aspect of digital papyrology, that it is collaborative and that everyone can contribute and make the tools better. So after a few months of work, we were able to collect a first data set that was made of 50 images of 10 writers. That may seem a lot for papyrologists, quite rich and nice catalog. That was very little for computer scientists. So we push more efforts to extend this first data set that is now 120 images of 23 notaries. They are all accessible on the website. And the idea was not only to work for the computer or for the computer scientists, but to provide resources that would also be useful for papyrologists. So displaying this annotation would already be useful tools for paleographers and specialists of the Dioscorus archive. And the annotation allows to show clearly which part is written by which writer on the image, and also to display conveniently the different samples from the same writer. You see that the digitization, preservation are very diverse. And of course, we had to take what we were able to collect. So the data set is not balanced. Some writers are very well known with 6, 7, 8 texts that are signed and for sure from their hand. Some others are only known by one text of which we don't really know the date. So you see that's the slashes, for instance, for Theodosius. We have one text and we don't know where it is in the timeline. But still, it was enough to evaluate the performances of the state-of-the-art methods. I don't have the time right now to go into details on the different experiments that started in 2019 and until today. If you are interested by this or by anything else that I will be mentioning today, do not hesitate to contact me and I will be able to go further into details. So you see, the idea is that you try to compare different patterns, and you can define patterns by key points on the images, or by cutting the images in small patches that may contain, for instance, 2 lines and a few letters per line, or just 1 or 2 or 3 letters, or even you see on the lower left, you have patches that contain only parts of letters. And you can also try to compare the segment of lines. Maybe you will have guessed, we have not reached 96 or 98% accuracy with this material. The best we could achieve, the best we could achieve was a little below 70%. So that's much less than the previous experiments on other data sets that are less challenging. I will just show you a bit more in detail the last one, the most recent one from December 2024, where we were using these 120 images, but we added manual labels. So we were comparing automatic patches to carefully manually annotated patches. And since it is very cursive handwriting, it is difficult to annotate just individual letters, because with ligatures, you don't really know where the letter starts, where the letter ends, and they will be distorted by what is before or what is after. So we give it a little try, but also we annotated the group of letter chi, which is the most frequent word in ancient Greek, that we had the more chances to encounter in each text, even if they are small and damaged. So by doing this, we could also develop a viewer that is called Palex, that allows to see the annotations on the image, but also to see them in a glimpse. So imagine you open several documents like this and you have all the chi, and you can navigate from the patches to the big image. If you click on one image, on one small image, you have the full image that appears. So you can see the context, you don't lose the context. Again, with this data set, we were very unbalanced. You see, for instance, Abraham had a lot of material where a notary like Amais, the second one, has very little because he is only attested in 2 documents. If the results of 70% are a bit disappointing, it is worth to look more into details in these results. So maybe some of you may not be familiar with confusion matrix. The confusion matrix gives you the true label on the vertical and what the computer has given as a response on the horizontal. So if the computer had given only good responses, you would have all the numbers in the blue diagonal, and none of them would be in the red boxes. So each red box is a mistake. And you see that there are a lot of mistakes. But among these results, there are also good responses. And for instance, Dios, number 7, has been identified at 100% success. But when we look closer, who is this Dios? Dios happened to have written only one very long document that is well preserved and in one place, so digitized in the same way. And in these very good conditions, we can see that the computer managed to recognize the writer without any mistake. If we look a bit closer, we see that it happened to two other writers, Colutos and Theodosios, that are also attested in one document each. At the opposite, Abrahamios, you may remember, the one that has the most material from his hand, he is attested in 17 different papyri over almost 30 years. So we have a material that shows a great diversity in terms of preservation, in terms of digitization, but also the handwriting of Abraham has evolved over the time and with different writing implements. So we see that if writer identification does not work yet well enough to be useful for the Dioscorus archive, it is especially because of this variation within individual handwritings, what is called the intra-writer variation. And it is the frontier that we are still working on to find what makes the Kai by Abraham unique compared to all the other Kai, although Abraham may have different ways of writing Kai. So this is where we are now on writer identification, but we are hoping to improve, to fine-tune, and as you have started to see, to be able to use AI as a support, not hoping for the right response right away, but as guidance and as a selection tool for human writer identification. If you're interested by this topic, that will be my topic in Cologne Congress in July. So my second point now is the script characterization. When I was working for writer identification, I also wanted to compare, really to be sure to compare apples with apples. And so I wanted to compare the shapes of individual letters. And for this, I used a different data set that are the papyri from the Iliad of Homer. Because it's the book of antiquity, we have 1,500 papyri that have been identified as bearing the text of Iliad, and they illustrate the evolution of the handwriting, of Greek handwriting over a millennium. But this dataset is also challenging because you may know that the dates are quite complicated. They are not, in very, very rare case, you have some objective dating, otherwise it is on the paleographical grounds. And we don't have any mention of writers. It is not a period where you have colophons. It is before. And the style typology has been a matter of discussions. Of course, there are different styles and canons, or we can discuss how we call the script unity. But there is also quite some discussion in the shades of gray that comes between the different canonical types. So with this challenging data set, the approach that has been chosen is to go at the character level. With my colleague Olga Serbaeva, we used a platform called Read to annotate the papyri at the character level. So you see, drawing manually the bounding box around each letter, which allow to then to look at all the alpha in the glimpse, to have a sense of the alphabet on the right, and also to assign tags to the letters. So these small images we call cliplets that contain only one letter. And we decided as a methodology to annotate all the letters on the papyrus, even if they were damaged, because since it's the Iliad, we know what we are supposed to read. We know the words that are in the Iliad at this passage. But we assigned tags to mention that the letter, for instance, is very damaged. You see the third category, BT3. It would be difficult to be sure that these are alphas if we didn't have any context. BT1 are well preserved, almost complete. We gave up on totally complete on papyri because there's always a little bit of ink that may be missing here and there. And the category BT2 is the pattern is complete, but sorry, the letter can only be identified as one letter. So even if you don't have the context, we could say that all these letters are alpha just by looking at them and not confuse them with lambda or delta, for instance. Once papyri are annotated at the character level via Read, we can use again this Palex viewer that allows to navigate quite smoothly between these different texts and look at the different letters that you're interested in. Again, being able to go back to the full image if we want. But these annotations can only also be exported and generate new data sets of thousands and thousands of these small images. Having these images can already be useful to try to sort them manually. And this is what we tried to do quite naively, trying to organize on rigorous categories and characteristics. And it turned out to be a nightmare quite soon because there are different levels of description. So it was very difficult to keep it hierarchical and coherent in front of such a number of levels of gray. So could the computer help us sorting letters according to similarities? This is the experiment that we did in the summer 2023. In this big conference that is called EGRAPSA. And we took 72 literary papyri that have enough material that were well preserved. And we selected only three letter types, so the alpha, the epsilon, and the muse. That gave us more than 5,000 cliplets of small images. And we used a neural network that is called SimSiam that is used to compare the faces, so images of human faces, and find the ones that are from the same individuals. How does it work? Well, you train the computer by telling that what we call similar are two examples of the same letter from the same document. We have checked before that there is no changes of hand in our papyri, which is quite expected on the Iliad. They are small, and in this case there was no suspicion of change of hand. So we defined similar the cliplets that were coming from the same papyrus, and from this the computer is able to generate similarity scores with all the other images in the data set. So it can give you, for one image, it can give you the most similar ones in the data set. And you see that And this is quite convincing just by looking at the results. It's not perfect, but it's interesting. And you can combine the scores to have an organization by similarity of all these texts. And so you have to imagine here that this is, you have to choose the threshold. So you would move the cursor. At the beginning, all the points are isolated, and then they start to link together according to similarity. And at the end, they would be all linked together. So at this moment, there was some clusters that started to form. And by looking at them manually, which takes time, there was some coherence that started to appear. So the early Ptolemaic texts were grouped together, the Alexandrian majuscule were close one to another. For instance, the biblical majuscule had been almost well grouped. Quite strangely, there was some serif style in the middle. So this was a bit surprising. And so this is the general view, but we can also have a detailed view. And for instance, these two mu were really very, very similar. And looking at these two texts on Palex, one can easily check that indeed this handwriting is extremely similar with the same balance of the alpha, all the letters. You may say that maybe the hook of the alpha on the right, of the text on the right, is little more than the one on the left, but it is really tiny. Kappa are extremely similar, and the general proportion of all these letters are very similar, except one. So there is just for one letter out of the 23 that you have clearly two different ductus. For the epsilon, you see that the epsilon on the left has first a long vertical stroke and then an arm. Well, the epsilon on the right has this kind of hoop of, it looks a little bit like a bird. And where are these two texts in the general tree? They are grouped on the left with this third text that indeed has some similarity, although using a different type of pen, you see, with more chiaroscuro. And also we could say that the balance of the characters are slightly different. If the recipe, if the order of stroke is very similar, the equilibrium of the letter is a bit different. And just to show you how once you have this map, you can navigate. Once you have the map and the Palex, you can navigate. If we look at the other texts that are similar, you will see that this one, for instance, has also this very curved mu, but here the alpha is a capital alpha. That reminds the one you may know of the Hawara papyrus, where you see the alpha is capital, the mu is very low, has a curve that is very low, and now the epsilon really looks like a modern Y with quite balanced arms around the vertical foot. So from these encouraging results, we did some more experiments on this similarity among styles, and we gave it a try on biblical majuscule. So if you're interested, I invite you to look at the video, and the article is forthcoming. So we could look at different hands from, different manuscripts written in biblical majuscule. And this is how the results look like. So you see at the beginning, all the dots. So each dot is a letter and each color is a manuscript. And you can have a small video where you see the similarities that group. And at any time you can stop and look again. You see what is going on. Oops, sorry. And the idea is, Sorry. The idea is to stop and to see when the letters start to join with other manuscripts before they have finished to join with the letters from the same manuscript. That would mean that the similarity is at least as high or higher with letters from another manuscript than the letter with one same manuscript. I think that can be a way of arguing that two papyri are from the same hand if their similarity is that high that they score higher than with their siblings from the same papyrus. So we could draw some graphs, similarity graphs, and then estimate the similarity scores within this group of biblical majuscule that look very similar one to another. We could still define more similarity. We have grounds to argue that some are probably from the same hand, or at least previous scholar has estimated that two manuscripts were probably from the same hand. And now we can argue that if we consider this as valid, we have also to include another manuscript that has such high similarity scores. We were also able to suspect that within the images of some manuscripts, one image, one fragment may not be from the same hand as the others, although they were grouped as one manuscript. So these were very interesting results. So now for the last part of my talk, I would like to talk on the most recent advances in this EGRAPSA project that started in June 2023. As Christian has kindly reminded at the beginning of this talk, the topic of EGRAPSA is to retrace the evolution of handwritings. The idea of evolution, of course, is the first one that comes to mind is chronological. So being able to see the evolution through the dates. But as you have seen, and you probably knew before, there is not only the question of the date, there's the question of the type of text, the type of writer. So at one given year, there is not one typical handwriting. There's no such a thing. So by gathering ground truth, we can display examples of known handwritings of which we are sure of the date and sure of the social-cultural background of the writer. So these are the blue dots that would be again our ground truth. And once we have collected this, we can use the AI to locate an unknown text in this panorama. To say, to the best of our knowledge, this looks like a notary handwriting from the 6th century, something like that. So in EGRAPSA project, I have the chance to work with a great team, Olga Serbaeva, who was already in this scribes, Lavinia Ferretti, who is a postdoc in papyrology, Giuseppe De Gregorio, who is a postdoc in computer science, Pedro Garcia Barro, who is a PhD in papyrology, and Ding Wang, who is a PhD in computer science. So you see a team that is balanced between papyrology and computer science. And the first output of EGRAPSA is, again, a data set of dated text of the Hellenistic period. Thanks to a collaboration with Pappal and Rodney Ast in Heidelberg, and to the great work of Lavinia Ferretti, we could collect almost 200 images that we are absolutely sure of the date. On this dataset, we took part with this dataset to this workshop of computational paleography last summer, to present an evaluation of the capacity of AI to date a papyrus. So it is the same idea as writer identification. Once you know the correct response, what is the date of this papyrus, you can teach the computer Okay, this papyrus is this date, this papyrus is this date, and then ask it what is the date of this unknown papyrus, of this new papyrus that the computer does not know, but for which we know the date. So this is what we did. And we could evaluate the accuracy of the responses by the computer. In this kind of experiments, usually in computer science, you have the kind of response that we reached an accuracy of 50 years. But be careful, accuracy of 50 years means that the response is no more than 50 years away from the correct response. But it can be away on both sides. It can be 50 years earlier or 50 years later. So that's why we rather count it as time window. So an accuracy of 50 years would be a 100-year time window because it has to go in both directions. And over our data set of 300 years, we could see that the accuracy, when we try to give a date within 50 years or within 100 years, is a bit, it's quite similar. But what we did is to look more into details on the results given by the computer. So on this graph, you have the X, that is the correct date that we know from the ground truth. And all the responses by the computer is in this little shape, the line and the rectangles. So sometimes you have also this vertical orange line that shows the average response. You see that for some papyri, for instance, the computer gives a lot of different dates. So imagine each papyrus has been cut into different pieces, and the computer tries to date the different pieces. And for two pieces that come from the same papyrus, sometimes the computer will give responses that are 2 centuries apart. So you see, for instance, the dark blue, that is 6 line from the top. It gives the computer have a good average, but the extremes are quite diverse. So sometimes it's very wrong on one side, sometimes very wrong on the other side. We were curious to see if some of these handwritings were possibly not looking their age, like elegant persons. And so we evaluated also some human experts' responses. We asked 5 papyrologists to make this little experiment. We guaranteed their anonymity, so don't ask me who they were. But the result is that the computer, in average, does better than the humans, but does not better than the 2 best humans. So there's the question of what is an expert, and this papyrologist may have been very good experts in Hellenistic papyri, but not necessarily in the paleographic dating of Hellenistic papyri. This is quite complicated to evaluate. So we will continue these experiments, but with a larger data set that will cover the millennium. And if we keep reaching a good average at 50 years time window, I guess we would be all very happy. So that's forthcoming. But already we were trying also to understand the evolution of handwriting. So this is a preliminary work by Lavinia Ferretti to visualize the different shapes that we encounter. And we were looking for a way to make it on the dataset, on a database available online. For this, we chose the platform that is called NodeGoat. That is a RDF platform it's a kind of pre-formatted database. So if you put coordinates for a place, then it puts it on the map. If you fill a field for dates, then it can create a timeline automatically. You have functionalities that are already there. Nice visualization tools. So for instance, you can see how is the distribution of your data set, how many texts you have for each period. And if you click on one of the blue lines, you will see the texts that are corresponding. You can enter the metadata that you find relevant for this text. So we chose the place, the date, of course, the reason for dating, the type, macro type of document to evaluate the social cultural background of the writer. The platform allows to see the image, and with Palex, we can visualize the cliplets. And now we are moving through the visualization tool to see the cliplets per year and to be able to navigate more. The question will be not to show everything, because you don't want to see 1,000 images on the map. So we are working on the methodology to evaluate, for instance, prototypes of letter shapes, or to express the variability of the letter shape per document. So imagine that the scribe would be a robot. It would write all the letters extremely similar. All his alpha would be overlapping, for instance. Then you would have all the dots at the same distance from the center of the circle. And another writer would be very messy, and then you would have dots at different distances from the center. That would be our idea of expressing the regularity of hand of one writer. With the PhD student from computer science, we are working also on the definition of allographs. I don't have time to go into details of that, but if you're interested, we can discuss on this. Defining the allographs by their composition, morphology. For instance, in Byzantine period, you have two clear allographs of kappa that can be encountered at the same in the same document by the same writers. And then you can, what I'm doing with the computer scientist PhD is to try to recover the writing movements to define which ductus has been done exactly by this writer. So this is still ongoing, and I hope to have more to tell you soon. So as a conclusion, I hope that I could illustrate the use of AI with its limits, also with its constraints, when it works and what it doesn't work. For sure is that AI offers a great potential for collaboration. For instance, we noticed the collaboration with epigraphists. So in the same workshop in Athens last year, we were very happy to see that the previous work we had been doing, a competition on a document on detecting and recognizing the letters of the papyrus, has been used in two different talks, one on Armenian inscriptions and the other one on ancient Greek inscriptions. So this is very impressive to see that the digital age allows transfer of methods and knowledge that, of course, the computer does not really care if these are alpha or Armenian letters. The methods can be applied with just changing the training material. There is an ongoing collaboration on the ontology, how to describe handwritings, how do we define allographs in terms of ontology and controlled vocabulary. This is ongoing as well. And what I would like to point out is that there is a great potential of collaboration with paleographers. So we have organized this competition on detection and recognition based on the work done on the Iliad, on the 200 images that were labeled manually. This was used as a training for the computer to recognize automatically. So what we are doing now is that we can use any new image of a literary papyrus. What I mean by literary is detached, isolated letters, not cursive for now. And we run our algorithm, and the computer automatically find the letters and find what they are. Of course, it is not 100% accurate, and there is a little work in cleaning the results, the automatic results of the papyrus. So my collaborator Giuseppe Di Gregorio has developed this tool that we call now Glyphix, and that allows to smoothly correct the few mistakes. So you may spot that on this first line there is one letter that is not an alpha, so you would go there and change the label. Or there are some way to find easily the overlapping bounding boxes and to erase, because you don't expect two letters to be written one on the top of another. And you can also draw new bounding boxes. So the idea is that we are open to collaboration with anyone interested. If you provide us with images, we can send you the automatic detection of the images and access to this tool so that you are able to curate yourself the papyri you are interested in. And once it is done, it comes with a format that is compatible with Palex, so you will be able to view the text in Palex, so all the letters and a link with the main image. And if you agree and you are able to share the data, then we can also run similarity measurements with the text we already have in the panorama. So as a final note to this conclusion, maybe sometimes AI is scary, maybe sometimes AI is totally left uncontrolled, and we need to be very careful about that. We need to have evaluation methods on the veracity and the correctness of AI. But this is also an impressive opportunity to tackle new challenges. And for instance, we did a little experiment to reconstruct an Iliad papyrus, because we know it's the Iliad, so we know what was missing in the lacunas. And once the letters are annotated, you can randomly choose different letters to write, so not using always the same epsilon, so because then it would look like a font, it would look a bit artificial. So here we randomly selected different shapes of epsilon and alpha to write the missing parts, and then the texture was automatically also restored behind the papyrus. So this can open also new ways in testing the different possibilities in the lacuna. Is it possible that this word was written with this kind of handwriting? And also to get an idea of how the full manuscript used to look like, reconstructing a roll to better understand how it was used. All this is, I found very promising. I just would like to finish by pointing also that when you do this kind of experiments, you always have to remember this idea that data matures like wine and software matures like fish. In papyrology, we are not so used yet to the idea of data. What do we mean by data? But if that can help you, what I think is very useful to understand that is to think that what is now TLG, the Thesaurus Linguae Graecae, and the papyri.info follows the same history. So these two projects started in the 1970s and were at one point on magnetic tapes. And then this data could be converted and is still usable now, whatever the software we access it. So when you do this kind of research, keep in mind to produce data, to publish data outside of the software that they are used to, the software that is used to consult them. And if you're interested by any collaboration or the topics that I've been talking about, there is the described mailing list to keep informed of digital paleography at large. I thank you for your attention.